about right. This is one of the hardest things to kind of understand and wrap your mind around, so I made this little animation to make sure you can try to understand it. So we're talking about orthographic projection versus isometric projection. These are two drawing standards, and they're the main two drawing standards you're going to see anywhere in drafting, in architecture, in engineering, all of that. So it's kind of a big deal to get your head around this. So starting out here, we're taking a peek at a cube here. And how we go from isometric, so this is isometric right now, I can tell because all of these angles are equal. 120, 120, 120. So those are isometric. All equal. To get to orthographic from isometric, basically I'm taking this cube and I'm unfolding it. But I'm keeping it all kind of connected. It's like a net in math class. And I'm continuing to unfold till they get all on a flat piece of paper. And then I square it up perfectly. So it's all squared up so it's exactly facing me. And what we would do then is just separate these away from each other a little bit and all the same distance. So if I'd separate this an inch up, I'd separate this an inch out, inch out, inch out, inch out. And that's how we get it. And we have 6 principal views here now. So we have front, that's our main view, top, right side, bottom, left side, and back or rear. And the back can either be on the left here or it can be over here on the right. It doesn't really matter. But it's just how we line it up. Notice that the width is the same in all the views and the height is the same in all the views. So that's how we start out here. Now let's talk about doing a little piece. Alright, we're going to turn this. Currently we're in isometric. We can go to isometric here, make sure we're in isometric. We're going to take this and we're going to put it in because this can't just unfold like that last cube did. Like this would fold up and then this would be a net. It would be kind of weird shape. What we do is we put it inside of a glass box. Okay? And inside this glass box, this is where the projection comes. So if I think about this, and these corners here get projected onto the surface at 90 degrees to it. So that's straight orthographic picture, straight picture projection. And these corners get sent out to this glass box. So if I take a look here, I can see how those corners are touching this glass box here. And then it's just a matter of connecting these dots. Connect where these touch. So I draw where those touch, boom, 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 and that's my shape. You can kind of think about it as if you were going to take a flashlight and put it on this side and shoot it this way. What would that shadow look like? And that's how I get my outside shape. Now that's going to change a little bit coming up, but that gets you an idea of how that works. So I do the same thing over here. I'd be shooting it to the left side. Be shooting it to the top. I'd shoot it to the right side. Kind of the same process here. I'd shoot it to the bottom. Same process you can see down there. And lastly, I'd shoot it to the front. Now this is what I was talking about a little bit. These look a little bit different. So notice this shape right here projects out to here, and this shape projects. So these are on the same plane, but there is this edge which is a line between them. So you got to understand that piece. If I was using a flashlight and shooting this in the back, this would just look like the outside shape. It wouldn't have this little line, but that little line would be there. Once we got all those shapes all done and projected to the glass box, then we start opening that glass box up. And then we fold it all the way, and you can start seeing what this looks like. So my front view is the front view right here. I have this piece, which is that piece, and I have this little piece right here, which is right here. Top view, I have this big surface, which shows up right here. This this medium rectangle and this small rectangle, medium and small rectangle. Looking at the right side, we have this larger rectangle right here. We have this shape right here that shows up. Bottom. So if I flip this upside down, I just see this full rectangle. Notice it's the same width all the way across. These are the same height all the way across. Moving to the left side. So if I go on the back side of this, I'd see this. And on the back, I would see that. Now, one thing I have not put in here is the hidden lines. So hidden lines come into play, for example, on this left side. If I look at the front, there's this corner here. But if I'm looking at it from the left side over here, I can't see that corner. So what I would do is I would draw a line across here. Dashed line, that's a hidden line. But we're not going to talk about that for right now, but just to understand that there is some stuff here that's happening. There'd be a lot of hidden lines in the bottom that actually looks like the top, but only hidden. This here I'm going to bring up. What this is showing is just your projection line. So this goes across and it lines up perfectly everywhere, all the way around. Project your information. So that is how we go from an isometric drawing to an orthographic projection. Hope this helped explain what we're doing there. Enjoy.